Now I'm going to discuss about the cubic equation of state. So in general, equation of state means any equation which relates pressure, volume and temperature. We know that the simple equation of state is the ideal gas equation of state, so that is PV equals to nRT. But that ideal gas equation is only applicable for the gases which obeys ideal gas, and all the gases are not ideal. So some gases in chemical industries we deal with the real gases and actual gases. But if you apply the ideal gas equation of state, the values which were obtained are not accurate. So that the many researchers worked to develop a new equation of state to represent the actual behavior of the real gases, that is the PVT behavior of the real gases. So now I'm going to discuss about the cubic equation of state. The first cubic equation of state was developed in 1873 by Van der Waal. Van der Waal's equation of state. It is tells about the actual behavior of the pressure, volume and temperature, and the equation is P equals to RT by V minus B minus A by the V square, where A and B are called as the Van der Waals constant, and that is given by P A equals to 27 R square TC square by 64 PC, and B equals to RTC by 8 PC. So this is the Van der Waal equation of state. P equals to RT by V minus B minus A by V square, where A and B are called as the Van der Waal constants. So 27 R square. TC and PC are the critical temperature and critical pressure of the fluid, and B equals to RTC by 8 PC. And the one more important point is ideal gas equation of state is only applicable for the gases, but whereas the gases we can find out the vapor as well as the liquid, the properties, pressure, volume and the temperature. So this is the Van der Waal first equation of state that is proposed in 1873. The latter in 1949 Redlich and Wong, they proposed another equation of state. It gives more accurate results than the Van der Waal equation of state. Redlich-Wong equation of state. So that equation is P. It is a little modification of the Van der Waal equation of state. So P equals to RT by V minus B minus A by T power of V into V plus B. So P equals to RT by V minus B minus A by T power 0.5 V into V plus B, where A and B are Redlich-Wong constants. So A equals to 0.42748 R square TC power 2.5 by PC, and B equals to 0.0866 RTC by PC. So this is the first equation of the cubic equation of state is the Van der Waal equation of state, and in 1949 the Redlich-Wong proposed another equation of state. So that gives more accurate results than the Van der Waal equation of state, and the latter in 1976 Sauvé modified the Redlich-Wong equation of state, and it was named as the Sauvé-Redlich-Wong equation of state. And it is popularly known as SRK equation. So this equation is given by P equals to RT by V minus B minus A alpha by V into B plus beta, where A and B are constant and alpha is a function of the reduced temperature and the eccentric factor, and it is mostly applicable for the hydrocarbons, to know the PVT behavior of the hydrocarbons. And then another equation of state is Peng-Robinson equation of state. And it was proposed in 1976. So, Sauvé-Redlich-Kohn equation of state was proposed in 1972, and the Peng-Robinson equation of state, it was proposed in 1976. And it is also a two-parametric equation. P equals to RT by V minus B minus A alpha by V into V plus B plus B into V minus B. So where alpha is a function of reduced temperature and the eccentric factor, and it is mainly applicable for the hydrocarbons and gases such as nitrogen and oxygen, to know the pressure, volume and temperature behavior of the hydrocarbons and the gases like oxygen and nitrogen. And another equation of state, the cubic equation of state, is Benedict-Webb-Rubin equation. In Benedict-Webb equation of state, it was proposed in 1940, and in this equation total 8 parameters are there. So the value given by this equation is more accurate than the other equations of state, but it is a very complex because 8 parameters are there, and this equation is P equals to RT by V plus B naught RT minus A naught minus C naught by T square by V square plus BRT minus A by V cube plus A alpha by V power 6 plus C by V cube T square 1 plus gamma by V square E power minus gamma by V square. So this is the Benedict-Webb-Rubin equation of state. P equals to RT by V minus B naught RT minus A naught minus C naught by T square by V square, BRT minus A by V cube plus A alpha by V power 6 plus C V cube T square into 1 plus gamma V square into E power minus gamma V square, where the parameters A naught, B naught, C naught, small a, small b and small c, alpha and gamma. So these are the constants. So this is called as a 8 parametric equation, and this Benedict-Webb-Robinson equation of state. It gives more accurate values than the other equation of the state, and it is applicable for the hydrocarbons, to find out the properties of the hydrocarbons. Therefore, most of the petroleum industries, they use Benedict-Webb-Robinson equation of state for measuring, know the values of pressure, volume and the temperature. And one more equation of state, that is Beatty-Bridgman equation of state. and this equation was proposed in 1928 and it has 5 parameters, and that equation is P equals to RT by V square, V plus B naught, 1 minus B by V, and 1 minus C by V T cube minus A naught into 1 minus A by V. So here the parameters are A naught, B naught, A, B, C. So these are the 5 parameters, 5 constants used in the Beatty-Bridgman equation of state, and this equation is applicable up to a pressure of 25 megapascals. So this is about the cubic equation of state, and in industries, based on the chemical industries, we can suppose if hydrocarbons, we can use Redlich-Kwong equation of state, or non-hydrocarbons we can use the Redlich-Kwong equation of state. So like that, based on the chemicals, we can select any equation of state to know the actual behavior of the fluid. That is PVT behavior of the fluid, PVT behavior of the fluid.